So, now we can go for the common base configuration and hybrid parameters about common base configuration. So, this is a logic symbol for NPN transistor. This is base. The base will be directly connected to the ground, and then the emitter current the emitter is connected to the ammeter, and then one voltmeter, then it will be connected to the ground, and then this is connected to the one resistor, then power supply. So, IE means in forward bias, the IE terminal is directly connected to the negative polarity of the power supply, is called as forward bias, and then the positive will connected to the ground. This is called as RE, emitter resistance, this ammeter and then voltmeter. Here we can connect the positive terminal, means here also we can put the positive polarity of the signal, and then here positive means here we can, the negative will be goes to ground, and then the ammeter negative part is connected to the IE terminal. The current will be like this, this is called as IE current, and then this is IB, then this is the forward bias or input characteristics. Then we can go for the reverse bias. The collector current again will be connected to the one ammeter, then voltmeter, then voltmeter other part is connected to the ground. Then here also we can put one resistor and then power supply. So, the collector is connected to the positive terminal of the power supply, the negative will be goes to ground. Okay. Here the positive polarity means here also we can put positive, and then this is negative, then this is IC current flow. So, this is the overall diagram of basic configuration about common base configuration. Then we can go for the hybrid parameters. Okay. So, we have 4 different type of hybrid parameters. That parameters are input impedance, output admittance, voltage gain, then reverse gain. First we can go for the hybrid parameter. First one is input impedance. Here we can put a name for this is VE voltage, and then this is VEB, because it can be depends upon emitter and then base. So, that is why it is called as VEB voltage, and then this current is called as IE. Then here VCB depends upon the base and then collector. So, this current is IC, and then this voltage terminal is VCC. So, input characteristics we can kept this one is constant. For output characteristics we can kept this one is constant, I mean emitter current. So, input impedance is defined as the ratio of HIB. Here why I can put the B means it is called as base configuration. So, that is why HIB is equal to the ratio of del VEB, because the voltage current to the emitter current, here the VCB is constant. The first parameter is called as input impedance. It is defined as the ratio of change in emitter base voltage to the emitter current. Then second one is output admittance. The output admittance is notated by HOB, is called as, the admittance means will be the ratio of change in voltage of collector and then base voltage, then IC. It is called as output admittance. there the kept as IE is a constant. And then third one is forward current gain. So, the forward current gain is defined as IC divided by IE, IC divided by IE. Here the constant is VEB. So, this is called as forward current gain. Then last parameter is voltage gain. Reverse voltage gain is defined as del of VCE divided by del of VEB. Here the constant is IE. So, these are the important 4 parameters about common base configuration. Then we can go for the input and then output characteristics for common base configuration. Okay, this figure shows the input and then output characteristics of common base configuration. First, I can explain about input characteristics. In input characteristics, we can depends upon the only forward bias condition. In x-axis, we can take voltage, base emitter voltage, then y-axis we can take only emitter current. Here we can put the constant as VCB. First we can put the 0 value and then VCB we can take 1 voltage, then 10 voltage and then 20 voltage. The graph will be like this. For VCB is a 1 voltage means the graph will be like this, and then we consider VCB is equal to 10 voltage means the graph will be like this, and then VCB is equal to 20 voltage means the graph will be like this. This is called as input characteristics. And then output characteristics. In output characteristics we have 3 important points about from output characteristics. First one is cutoff region, second one is saturation region, and then last one is active region. Here you can consider the voltage will be, the emitted current will be 0 means like this the graph will be occur. So, this region is called as cutoff region. So, this region is called as cutoff region, and then here 0 to up to this voltage, this particular area is called as saturation region, and then from this to this is called as active region. So, in output characteristics, some point we can go for the emitter current will be constant. Then this slide shows the comparison about active region, saturation region and cutoff region. For common base configuration, in active region IE increased, IC also increased. In saturation, BE and CB junction is forward bias, and then cutoff region below the line of IE is equal to 0 meter. And then second point is in BE junction forward bias and CB junction reverse bias, we can consider the first part as input characteristics forward bias, then second one is the output characteristics is here reverse bias. Then in saturation region, the small change in VCB will cause big difference to IC value. Then BE and CB is a reverse bias from cutoff region. The next point is IC not depends on VCB. The allocation for this region is to the left to VCB is equal to 0 voltage from saturation region, and then cutoff region no current flow at collector, only leakage current will be occurred on cutoff region point. So, these are the important points about common base configuration. Then we can go for common emitter configuration. So, the define common emitter configuration, already I told you the emitter configuration means the emitter is directly connected to the ground, and then input parts is depend upon the emitter and then base voltage, then output characteristics is depend upon the collector and then emitter voltage. Here also the almost amplifier design is using connection of CE due to the high gain for current and voltage. Now I can complete my lecture series. Thank you for watching. Thank you.